Chapter 3, Section 3, Solving Quadratic Equations. We've been working on factoring quadratic equations. We've solved a little bit of it, but now we're going to look at most all of the ways to solve quadratic equations, at least the easy ones. We're going to learn three different ways. One is graphing, which I'm not going to make you do by hand yet, unless I have been, then you can do it by hand. Or we're going to use the graphing calculator, a TI-83, 84, something like that. Or Desmos will be another great option. We're going to learn algebraically, where we just do the algebra. That's moving things from one side of the equals to the other. And or by factoring. That's the other way we're going to do it, which is why we've been doing all this factoring practice. So let's start with the first kind, right? Solving quadratic equations by graphing. Quadratic equation in one variable. Now it needs to be x only. We're going to replace the y part of it. Okay, xy is how it graphs. We're going to replace y with something important. That's going to help us know what the answer is. So anything that can be written in the standard form ax squared plus bx plus c equals 0. Typically b equals y, that's standard form, but we're going to replace y with 0 every time. And that's important. Okay, because what we're working for is a root of the equation. A root is the solution, is a solve for x, is find what x is, solve the problem, find the answer to the quadratic, solve the quadratic. Any of these ways of saying solve it, root it, solution it, find the root, what are the roots of the answer? That's the equation, that's what we're looking for, that's the answer. And they call it a root because we're really looking for the square root of things. It's a squared problem, we're going to square root it, we're going to root it out. We have different ways, graphing, using square roots, and factoring. We're going to look at all of those. So let's get started. Solve each equation by graphing. To solve by graphing, step 1, put it equal to 0. Okay, make a little line through it so you know it's a 0. It needs to be equal to 0. So if we look here, got a little equal to 0. So that one is ready to go. So now all we need to do is pull up a graphing thing. That's not really what I wanted. Let's see. Double click. Desmos is one of them. That's the easy one. Let's look at TI-83. Okay. Now, what I'm going to try to do here, if I can get back into here. And, nope, not that. There we go. That's what I was looking for. All right. This equals 0. That's technically the y. Okay, the y is over here. So you also have to have it basically set equal to y. If it's not all set equal to y, you're not going to be able to type it in here very well, and it's not going to work very well. So make sure you set it equal to y, and then change y to 0. We're not going to have to change it to 0 to graph it, but normally you would. Okay, but that's kind of the thing we do. So pretty much get it equal to 0, get it equal to y. Y is 0. We're replacing y with 0. Because what we want to know when we graph it, okay, let's see, I'll do black lines for this. And we get a parabola, it does something like this. What we're looking for is where it crosses the x-axis. This is the x-axis. The x-axis is when y equals 0, because this would be y is 1, this is y is negative 1, this is when y is 0. Okay, so we want to know when y is 0. We want to know the x part of it that does that. I don't know why I'm on that right now. Okay, that's what we're looking for. So we're going to type it in. So in big yellow calculator, the TI-84, okay, mine says 83, but it's more advanced than your 84. You need to go to the y equals button. It's upper left-hand corner. Clear out anything that's in there, and you're going to type in your equation. For x, you're going to use the variable button. Mine looks a little different than yours may at home, but it's right next to the alpha button. Yours will say x, t, n, and it'll have a little 0 with a horizontal line in it. It's called theta. It's the variable for degrees. Mine just has x, so I'm just going to push x. I'm also going to use the squared button because it says x squared, and then I'm going to push minus, not negative, but minus, and then another x, and then minus, and then 6, I don't have to put the equals part. The equals part's already on there. It says y1 equals. That means my very first line, my first y, it's going to be green on mine. Yours will be probably one color. If I wanted to, I could change the way that y did, either equals or less than or equal to, or greater than or equal. You can see that little scrub at the bottom. I just want it equal. And then I'm going to tell it to graph. Your graph is on the right-hand side. You can tell it to graph. My favorite is to tell it what to zoom. This calculator doesn't really have a zoom because it's got touchscreen pinch stuff, but yours has zoom. It's right in the middle of the very top set of buttons. And if you push zoom 6. That makes sure that you always go back to 10 up, 10 down, 10 left, 10 right. It centers your graph and zeroes it back to home base. So just do zoom 6 instead of graph every time. Okay. I'm going to go to my zoom and I'm going to push zoom standard so it puts it back in. Now what we have to do is we need to calculate something. So I got to click the line. This one's nice because it's touchscreen and I can just touch where the zeros are. You will have to go to calc, which is a second function. Now you see value, 0, min, max, whatever. You're going to calculate a 0, and then you're going to push, and it's going to ask you some questions. Left boundary, right boundary. So you want to go to the left somewhere. Okay, so I want to see if I'm looking at my graph. I need to be, let's see, the leftmost boundary. The farthest left I want to look is like, I don't know, -3. And the farthest right I want to look is 0. So you can put those in, or you can actually just move the cursor, press enter, move the cursor, press enter, and then, let's see if my cursor will move. I don't know if mine doesn't do that on the graph. And then you push enter, and it'll tell you there's a 0 at -2. So that's our first answer. Okay, so I'm going to scrub all this out of the way. All we did was look at the graph. X equals -2. There's another 0 over there on the other side. It's between 2 and 5. So I'm going to go back and change these. Delete. Let's see. Go back over here. All right. 2. Delete. And 5. Enter. There's another 0 at 3. So we can do it graphically. Your TI-84 calculator graphing style is not the easiest one to do it, but you can do it. I can't show you all the buttons on this because I don't have a TI-84 on here, but you're going to have to go to that calc feature, okay, calculate. And then you're going to tell it calculate a 0, and then it asks you left boundary. Move the cursor over to the left past where it crosses the x-axis, press enter, move it to the right of where it crosses past that part, press enter, and then it says calculate, yes. Or guess, I think is what it says. And push enter, yes. And then it will boop, figure out 1 0 for you. Then it'll figure out the other. You can also go to your table. Because what we're looking for is when y is 0. And so you can scroll through your table and look in the y1 column and see where it says 0. I got 0 at -2 and I got 0 at 3. Those are my zeros. Okay. The easiest one is Desmos. X squared minus x minus 6 equals, now it has to be y in this sense, so they'll graph it. Look what happens if I say 0. Okay, it does do those same dots, but I want it to be y here, just like I do y equals on my TI-84, and then all I have to do is boop, boop, and that tells me those are my x's, -2 and 3. That's what I'm looking for. We like Desmos. Desmos works very easily. It's very nice. Okay. So, on B, number 1, set equal to 0. It is not, so I'm going to move my 4x. So -2x squared minus 4x minus 2 equals 0. And I'm going to graph that. Let's see. Boop. -2x squared. Forgot my 2. 2x squared minus 4x minus 2 equals y. Boom. It only touches in one place. -1. So you'll get 2 answers, 2 different ones or 2 of the same ones. You'll get 1 answer, which is actually the same thing twice. because it's like the left arm and the right arm are both coming down and touching it. X is -1. Or we will eventually get no answers, which we'll talk about in a later section. Okay, but that's doing it by graphing. Type it in, y equals, put the equation, boom, there you go. You can even just do left and right sides. Okay, we know what the right answer is, so let's look. If we type in the left side, -2x squared minus 2 equals y, and 4x equals y. Type them both in and see where those lines touch. They touch at -1, -4. The x part of that is -1. That's the part that we need. You don't have to, in Desmos, set them in two different places, or even your other one, but you got to solve for different things. Instead of calculate a 0, you're going to calculate an intersection and tell it where to look for that intersection. Graphically is probably the easiest. As long as you're using Desmos or something like it, you can find it pretty quick, but it takes a while. You should be able to algebra a little faster in your head. Now, let's look at algebraically. There's two different ways algebraically. There's algebraically that I'm going to refer to, and then there's factoring style. They think both of those are algebraically, but we'll just look at this one. When solving quadratic equation using square roots, you can use properties of square roots to write your solutions in different forms. When a radicand in the denominator of a fraction is not a perfect square, you can multiply the fraction by an appropriate form of 1, so the same number top and bottom, to eliminate the radical from the denominator. This process is called rationalizing the denominator. The reason it's called rationalizing is because we want a rational number in the bottom of the fraction, in the denominator, and not an irrational one. A square root that doesn't simplify is irrational. We can't have that in the bottom. It's a no-no. So you just have to get rid of it, and I'll show you that when it comes around. Okay. So basically what we're going to do is we're going to solve algebraically. And what we want to look for is no x. X squared works. No x. Can't have the linear term of this. If there's a linear term in there, algebraically doesn't work. You have to do it factoring or graphing. But since we don't have an x number, okay, we don't have a linear term, we only have a squared quadratic term, we can solve it algebraically. We're going to try to get the x squared by itself. Then the last move, to undo square root. So, move your 31. Okay, remember, SAD map, add, subtract, away. Start on the outside, work your way in. And we get 4x squared equals, let's see, 50, 60, 70, 80. Okay, equals 80. Divide by 4. Get the x squared by itself. X squared equals 20. And then we're going to square root. Square root both sides. If you do it to one side, you got to do it to the other, right? The square root of x is x, right? We have a little factor tree, x and x. There's a pair up, so it comes out. Now, the square root of 20, let's break it down. 4 times 5, that's broken. 4 times 4, 2 2's. There's my pair up. 5 doesn't pair up, so it stays in. So 2 square roots of 5. Now here's the problem. When you're dealing with squares, like if we did 3 times 3, 3 times 3 is 9. But if we do -3 times -3, we also get +9. So if you square root a positive number, you technically get two answers. You get the primary answer, which would be 3, and then you get the opposite answer, -3. So not only do we need 2 square roots of 5, but we need both kinds. We need positive and negative. So we put the plus or minus symbol on it and solve. Okay. Let's look at B. B has a squared term only, no linear term, no single x, so we can solve algebraically. Move the 9. 3x squared equals -9. Divide by 3. X squared equals -3. Well, here we run into the problem. Okay? You can't have a negative number and then try to square root it. It doesn't get you a real answer. Because the only way to get to -3, or any negative number, is a negative times a positive. And if you have one thing positive and one thing's negative, they are not the same thing. So they are not being squared. So this, when you see a negative, so let's change colors. When you see, not negative, but a negative in the root, in the square root, no solution. Can't do it. Okay. So as soon as you get x squared equals a negative number, you're done. No solution. Okay. Now see, oh my God, scary, fraction. That's very easy. Okay. We're just going to multiply by its opposite. We're going to get rid of a fraction. We're multiplying by 2 and we're dividing by 5. So all we're going to do is do the opposite of that. We're going to divide by 2 and multiply by 5. And here, we'll multiply by 5, divide by 2. These cross, those cross reduce, leaves us with x plus 3 squared equals 25 over 2. Give me some more room here. Then we square root. X plus 3 equals, we get plus or minus, we get both answers when we square root. When we're solving, you get 2 answers. When you just square root, you get 1. It's just the primary. But if you're solving, you need both kinds. Okay. So here, we've got the square root of 25 over 2. We haven't gone over these, but we will and refresh, but I'll do them right now just to refresh your memory. Radical rules, we can actually make that the square root of 25 over the square root of 2, which becomes 5 over the square root of 2. This is the part you can't have. You can't have the square root of 2 on the bottom. This is where we have to rationalize the denominator. Okay, that's the problem we're going to have. We can move the 3. And then we get x equals negative 3 plus or minus 5 over the square root of 2. This, that's a no-no. Can't have that. So what we're going to do is we're going to multiply by the exact same square root we can't have in the bottom. And here's what's going to happen. Negative 3 stays, the plus or minus stays. 5 times the square root of 2 is 5 square roots of 2. A square root of 2 times itself becomes the square root of 2 squared. And the square root and a squared cancels out, and we just get 2 on the bottom. There's our answer. Negative 3 plus or minus 5 square roots of 2 over 2. You can see why those square root abilities come in handy. We're going to be using them a lot since we're going to be square rooting things. Okay, so solve using square roots. So here we go. We have to do it that way. We don't have a linear term in 4, so give 4 a try. Pause, give 4 a try, and come back and see the answer. Okay, here we go. Minus 14. 2/3 x squared equals 6 times 3 over 2. That scratches to a 3. Those all went. X squared equals 3 times 3 is 9. Square root both sides. X equals plus or minus, not square root, just do the square root, 3. Give 5 a chance. Okay, here we go. Subtract 1. Negative 2x squared equals negative 7. And there you're thinking, there's a negative there, but be careful. Negative 2, x squared equals 7 over 2. Square root. X squared, nope, square rooted. Now it's just an x. X equals plus or minus square root of 7, square root of 2. I just went ahead and split them up already. I'm going to multiply by the square root of 2, the square root of 2. X equals plus or minus square root of 14 over 2. with a radical. If it's the same index, this one's a little 2, that one's a little 2, they're both square roots. You just multiply what's underneath. So square root of 7 times square root of 2, square root of 14. Square root of 2 times square root of 2 technically becomes square root of 4. 4 square root is 2. But a radical times itself is the radicand, the thing underneath it. And so we're right there. We cannot reduce the 14 into 2. Even though 2 goes into 14, it's not really a 14. It's the square root of 14. So it stays right there. Let's check the last one. Okay, before we get rid of the exponent part, because we are doing sad MEP this time, look for subtract, add, take away. Well, I can't add the subtracting 4 because that's inside the P first. So I can't do that. I don't have anything to add or subtract away. So then I look for divide, multiply away. So the 2 times the parenthesis, that's what I want to get rid of. So divide by 2. So now we got x minus 4 squared equals negative 5 over 2. I'm going to square root, but I can't square root a negative yet. So right now, no solution. Just like that. Now let's do factoring. Okay. Solving by factoring. Number 1, set equal to 0. Number 2, G, C, F. Okay. So subtract the 45. So we've got x squared minus 4x minus 45 equals 0. You can't do this one algebraically because of the linear term, the x. So now I have to figure out, okay, my a is less than 1, no greatest common factor. Separate into factors, each one gets an x. Factors of 45 that subtract to 4. I got 1 and 45, not 2. Let's see, 3 goes 15, that subtracts to 12. 4 goes, nope. 5 goes 9 times, subtracts to 4, that's what I'm looking for. I want 5 minus 9. Opposite to get out, so x is negative 5 or positive 9. Both answers. Okay. So these are also known as zeros of a function. Okay, these are known as zeros. This is called factored form. Okay. That's what we're looking at there. Intercept form, even. If you factor everything out and factor it, either one has to be 0 for it to be equal to 0. That's a zero product property. We've talked about that one. Okay. Now, and as soon as they say function, they're just talking about this thing. That is basically like saying Bob. Bob equals this. They're function of x. It's like you're doing work with the variable x. Here's the expression that does the work. You might as well say y equals. That's what I like to think of and use, is the old y equals. Okay? So let's keep trying it. So here we go. All we got to do, since that's y, and the first step is set y equal to 0, is just go 0 equals 2x squared minus 11x plus 12. Let's see, do they have a greatest common factor? No, they don't. So slide to the back. X squared minus 11x plus 24. X factors of 24 that add to 11. You got 1 and 24, you got 2 and 12, you got 3 and 8, you got 4 and 6, 3 and 8 add to 11, 3, 8, both are minus. If you slide it, you must divide it. 0 equals x minus. I'm going to leave it 3 over 2 because I'm in solve mode and not factor mode. 8 divided by 2 is 4. Because all I have to do when it's x minus number, and x minus number is opposite to get out. So x is 3 over 2, x is 4. We could even check our work. Let's see. 2x squared, that's what I wanted, minus 11x plus 12, and boom, boom. 1.5, that's the 3 over 2, and positive 4. Bam. Got them. So I can even check my answers graphically if I wanted to. Works out just as well. So we've got two different kinds here. 7 and 8, solve them by factoring. 9 and 10, find the zeros of the function. They didn't really tell you how to solve, but I'm going to say do it by factoring. Okay, do it by factoring if you can. So try 7 and 8 right now. Give it a pause, try 7 and 8. Let's do 7. X squared plus 12x plus 35 equals 0. No greatest common factor because the a is a 1. So each one gets an x. Factors of 35 that add to 12. Well, 1 and 35 is 36. 5 and 7 is 12. X equals negative 5 and negative 7. I'll do... Let's erase that. Let's do 8 in blue. 3x squared minus 5x equals 2. Move your 2. Get it set equal to 0. 3x squared minus 5x minus 2 equals 0. They don't have a greatest common factor, so slide to the back. X squared minus 5x minus 6 equals 0. Factors of 6 that subtract to 5. Let's see. Factors of 6 that subtract to 5, that would be 6 and 1, and we need a negative 6 and a positive 1 so we can get to negative 5, and if you slide it, you got to divide it. So x minus 2, x plus 1/3, opposite to get out, negative 2 switches to positive 2, positive 1/3 switches to negative 1/3, and we are out, and those are our solutions. You can plug them back in and check them. You can graph it and check them. All of that works. Give it a pause. Try 9 and 10. Okay, here we go. Let's see. Give it a little erases. Start with red. Number 9. F of x is basically a y, so make it 0 equals x squared minus 8x. Greatest common factor, if you can first, well, looky right here. They both have an x. So I'm going to say 0 equals x times x minus 8. This is factor 1. That is factor 2. That's like plus 0 in there. So one of my x's is 0. The other of my x's is negative 8. Opposite to get out, positive 8. Little trade secret there. Take out that greatest common factor. I could have put a, if I wanted to, put a plus 0 on the back, and factors of 0 that add to negative 8 would be 0 and negative 8. So, but a little quick thing, knowing about factoring and factors, greatest common factors and all that business. Let's do blue for 10. All right, that's basically y. So 0 equals 4x squared plus 28. Ooh, there's 2 in there. 28x plus 49. It's got 3 parts. It's got a plus at the back, and the big clue is 4, perfect square, 49, perfect square. I'm going to bank on perfect square special pattern. 2x, 2x, 7, 7, plus, plus. 2x times 7 is 14x. 7 times 2x is 14x. 2 14s makes 21. Boom, so there I am. But I don't have just x plus number right now. So if I opposite to get out, I'm going to be missing something. So just like whenever we have the fraction and we're going to put it in factored form and we just go, we slide it in front of the x, we can go whoop, slide it back here and make it a divide. So we get 0 equals x plus 7 halves and x plus 7 halves. So x equals, opposite to get out, negative 7 halves. And we get it twice, but we only have to write it once. Just touches right there. Okay. If you want to see the work on that, I'll show you over here. 2x plus 7 equals 0 minus 7. Let's see. 2x equals negative 7. So divide by 2. X equals negative 7 halves. That's what happens when you set it equal to 0 and solve for x. You can do the opposite to get out also. Now, real life problems. Maximum or minimum value of a quadratic function. You can first use factoring to write the function in intercept form, because the vertex of the function lies on the axis of symmetry, which is p plus q over 2. The maximum value or minimum value occurs at the average of the zeros of p and q. So, basically what they're saying, if you have, let me draw two different little things here. A graph that goes like this, or a graph that goes like that. This one is a max because it's got a peak, it's got a highest point. This one's got a minimum, it's got a lowest point. One of these is P, one of these is Q. Okay, the axis of symmetry, okay, the vertex, this point right here, lies halfway in between P and Q, or the average. So if you figure out how far P to Q is, and you divide it in two, that's the point right here, and that's the X part of this. So if you want to find out how high or how low it is, you plug that X into the equation, and you can solve for it. Doing it graphically is even easier. We're going to go Desmos, or go with the TI-84. I'll show you both. A Monthly Teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each $1 increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue? And what is the maximum annual revenue? So how much do they need to charge? What's the best price? And then what do they actually make when they charge that best price? Okay, so how does math apply to the world? Here's a good real world situation that we can look at. Okay, so first we need to figure out what our variables are. Okay, so let's define some stuff. Let's say that X is equal to the price increase. X equals the price increase. Okay, X equals the price increase. So by how many increases you do for every $1 you go up. So that's the how many increases are you going to do. That's X, right? The base price is 20. Okay. And then we're going to say, as they do in the book, we can call it R of X. The reason they're calling it R is because it's the total revenue, or how much money they make. R of X is the annual, and I'll put revenue. Okay, so now we need to make an equation. So R of X is equal to, okay, the number of subscribers times the subscription price. Well, the number of subscribers, they tell us, starts at 48,000, but it goes down by 2,000 subscribers for every price increase that happens. And our price is going to be $20, but it goes up every price increase that we do. So then we got to multiply those bad boys together. Okay. They actually do this in a very interesting way. They say, okay, well, look at these guys and look that they have a common factor, right? They have a common factor of 2,000 that we could pull out of there. And if we pull out a negative 2,000, we'll make the X positive. So the way they do in the book is they go like this, and they say, okay, if we pull out 2,000, we can make that 24 plus X times 20 plus X. Well, if we rearrange those using the commutative property, we got 2,000 times X plus 24 times X plus 20. So those are our intercepts. So on our graph, and we are trying to maximize, right? On our graph, our intercepts are at 20 and 24. And so we get this peak up here somewhere like this, and we want to know where that is. Well, if we take 20 plus 24, the P and the Q, and divide it by 2, we get 44 divided by 2, which is 22. 22 is where our peak happens. So on our first question that they asked us, how much should the magazine charge to maximize annual revenue? They should charge $22. I just put 25. That would not maximize revenue. They would actually lose money. They should charge $22. And then what is their maximum annual revenue? So what is the max? Well, we'd have to plug that in. I'm going to plug it into the old Desmos calculator and see what happens here. So if we say y equals, I wanted a y, and we go parenthesis 48,000 minus 2,000x, close, open, 20 plus x, close. We can't even see it. Oh, was one of those positive, one of those negative? Oh, it was. Look at that. You didn't let me do that. I should have changed that to a negative 24, which would make that minus 24. This is why we always check our work. Graphing makes it easy. So it could have been $24 or negative $20. Should have known that anyway. So negative 20 and 24 makes 4. And we divide that in half as 2. So it's still the amount of increase we should do is $2. So they should charge $22. Still got that part right. But our graph is bad. Should look a little something like, what was it? Back here. Negative 20, and it's going to arc this way. That's better with their increase. So now we want to know our maximum. So we said, what if we put in 21, right? Well, we can shrink our maximum. Whoop, whoop, whoop. Yards. That's way up there. Remember, it was 48,000 subscribers. So this is where making graphing one of these things very hard. And if we want to plug in something, it's so far up there. Okay, so I'm going to go back to the main graph, and I'm going to say, what if we make x equals 22? Right, or actually we want to make x a 2. And then where do they intersect? This is also not a good way to do that. Okay, I got a better idea. So instead of this, let's just go back in here and go, okay, parentheses 2. And we're going to go over here, and we're going to say a 2. $968,000 is what they get. So $968,000. Nice chunk of change. I would have done this in a little different way. I probably would have multiplied all of that together and got a big equation to start with so that I could plug that into my y equals. Let's look at if we do TI-83 style, go to our y equals, go to clear, parenthesis 48,000 minus 2,000x, close, times 20 plus x, close, and we go graph. And mine works very nifty where I can send this in here. Okay. I can even make it look like a thing, but it makes it so much easier for me. But look at my scales, right? I'm going up by 200,000s, and I'm going over by tens. So that makes it very difficult to do. So one of your zooms that you can do if you do that middle zoom one is you can do zoom fit, and it will fit it into the screen for you. And then you can calculate min or max. Go for max. And you can see my little scrubber up there. I'm going to go, yeah, that's my left. Let's see, we know where it should be, right? It should be about $2 or so. About $22. Something like that. Isn't that what it should be? Let's see. Yeah, so calculate. I want the left to be 0. I want the right to be 5. I want to calculate a max. And it says 967,999.999999, which is $968,000. Okay. Real life ones are trouble because they are big money. Okay. Let's see. The magazine initially charges $21 per annual subscription. How much should the magazine charge to maximize annual revenue? What is the maximum annual revenue? So they just changed the first price to 21. So the nice thing about this is we can go back and look at our original equation. All we have to do is change up this one number right here to 21. How much do we increase this time? Okay. And then we recalculate all the revenue stuff. So if you wanted to do that, you get y equals, or the r of x equals, still 48,000 minus 2,000 per subscription increase. Starts at 21, goes up by $1, and we figure out, okay, that's what they initially charged, so how much should they charge up to make the max? Well, we can do the same deal. We can pull out this 2,000 that's in perfection. So we got 24 minus x. So we're going to change those because we pulled out the negative. We got 21 plus x. And then we can rearrange them. Negative 2,000, x minus 24, x plus 21. So our P is 24. Our Q, that is a weird way to make a Q. Our Q is negative 21, so our graph is negative 21 to 24. We want to be in the middle somewhere. So 24 plus negative 21 over 2 makes 3 over 2, which is 1.5. So they should charge $22.50. Because if we take 21 plus 1.5, we get $22.50. Then if we plugged 1.5 in to our equation, we could figure out what that maximum amount of money is. I'm going to go back to my TA83 because it's already in there. If I go done, back to y equals, and now all I have to do is just change that to a 1. Right? Just want to change that to a 1, then regraph it. And go zoom fit this time, get it on there. I don't know what that little tall place is up there. 101,000, because there's my 1.5 mark, right? Should be a max. 101,000, no, 1,012,500. So we get 1,012,500. So a little bit more money whenever you started bigger and then you increase the price. More people still like to buy it from you. Okay. Let's look at our last little word problem. Told you about this. Falling objects. This is kind of how it works. When you drop an object, gravity affects it quadratically. So when an object is dropped, its height, h, in feet above the ground after t seconds can be modeled by the function h equals negative 16t squared plus h sub 0, where h sub 0 is the initial height in feet of the object. The graph of h equals negative 16t squared plus 200, representing the height of an object dropped from an initial height of 200 feet, is shown at the left. We've got a picture over here. Here's the guy. He's got the object. He's dropping a brick on someone's head. It started at 200 feet. It falls. It falls at the speed of gravity, which increases quadratically. You get 9.8 meters per second, or about 32 feet per second. Now, because it's going through air resistance and other types of sciencey things like that, you do half of that. There's a whole big physics thing into why its acceleration is only half the speed, but it deals with velocity and some other things like that, so average velocity. So the model h equals negative 16t squared plus h sub 0 assumes that the force of air resistance on the object is negligible. Also, this model applies only to objects dropped on Earth. For planets with weaker or stronger gravitational forces, different models are used. So, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Write a function that gives the height, h, in feet of the container after t seconds. How long does the container take to hit the ground? So A has two parts. You have to write a function that gives the height and feet of the container after t seconds. Well, they gave us the original equation, right? It's up here. H equals negative 16 t squared plus h sub 0. Our starting height is 50 feet. So we're going to be, if we have to write a function, it would be f of h, so a function of height, equals negative 16 t squared plus 50. Starting at 50, going down towards the planet at negative 16 feet per second per second. That's what we do. How long does it take to hit the ground? Well, where's the ground? The ground is at 0. So if we set this equal to 0, we can solve for t. I don't see a regular old plain t, so I only see one t there. I could do it graphically, but it's going to be pretty big, and I have to deal with all the graphy stuff. I'm just going to, let's see, can we do the math? Yeah, I think we could do the math. Negative 50. Negative 50 equals negative 16t squared. 5 by negative 16. The negatives go away. Let's see, what goes into both of those? 4 does. 8 does not, so let's see. 4 does. Oh, not nicely. 2 does. 25 over 8. Okay, so we square root it, and we get t equals plus or minus the square root of, well, square root of 25 is 5. I did it. 5 over square root of 8. Let's see, square root of 8, 2 and 4, 2 and 2. Where's my 2's? 2 square roots of 2. 2 square roots of 2. So t equals plus or minus 5 over 2 square roots of 2. We're going to do it times this to rationalize the denominator. So 5 square roots of 2 over square root of 2 times 2 is 4. Now, that is not a very good answer for something that is like an approximately or a seconds thing. 5 square roots of 2 divided by 4 seconds. That doesn't work. Plus, we can't have negative seconds. So we could plug that into the calculator. Let's see, done. And we say, okay, 5, there's my square root button. There it is, second square root of 2 divided by 4 equals, so about 1.77 seconds. Now we could have also graphed it. The easier graphed it would be Desmos, right? And we go with y equals negative 16 x squared plus 50. And you go, well, it's either 1.78 seconds or negative 1.78 seconds. Well, you can't go back in time, so it's 1.78 seconds. Okay. Find and interpret h of 1 minus h of 1.5. Well, let's see. H on the outside just means they want us to do, oh, and actually it shouldn't have been f of h, it should have been h of t, right? H of t equals negative 16t squared plus 50. Because height is what we get out of using time. This is our y. And this is technically x, right? This whole thing is basically like y equals and then x squared. If you want to think of it that way, that's a way easier way to think about it than function form, okay? So what they say whenever they're saying h of 1 is after 1 second versus after 1.5 seconds. So h of 1 minus h of 5. Well, we'd have to figure out what h of 1 is. And luckily I have a thing for that. So if we say x equals 1, where do they both touch? Well, 134, so h of 1 equals 34, and all we're doing is plugging 1 into this. That's basically what we're doing, just whoop, plug it in right there. So 1 squared is 1. 1 times negative 16 is negative 16. Negative 16 plus 50 makes 34. And we want to subtract h of 1.5. Well, let's see. If we just change that to 0.5, where do you touch now? Ooh, right there at 14. 14. Or the other way to do that is do 1.5 squared, which is 2.25. And then you do that times negative 16, which is 36. And you do plus 50, which is 14. That's what we got. So 34 minus 14 equals 20. Okay. And that's how long it would take you. Okay. That's the height it would take you to get from there to there. You fall 20 feet in half a second. That's basically what's happening there. So that's kind of a nifty deal. And they're 20 feet apart. So that makes sense. Looks good.